Today we are solving Winter 17, Paper 32, question number 4. The question says, the curve with equation this has one stationary point in this interval. Find the exact coordinates of this point. So I have written down the equation here. So we have to find the exact coordinates of the stationary point. Okay, so we know that for the stationary point dy over dx is always equals to 0. So we need to find dy over dx of this equation. So it's in the form u over v, so we can use the formula given in the formula sheet here. This is the formula which we are going to be using, u over v. Minus u over v square. So in this case, our u is 2 minus sine x and our v is cos x. So the derivative of u will be, the derivative of 2 is 0. The derivative of minus sine x would be minus cos x. Minus will remain as it is and derivative of sine x is given in the formula sheet here. Under differentiation, it's here, the derivative of sine x is cos x. So it will be minus cos x. The derivative of cos x is minus sine x. Now I will input these values into the formula. Let's erase this. So v is cos x, u dash is minus cos x, minus u 2 minus sine x, and v dash which is minus sine x over v square. So v is cos x. Now we can simplify. So it will be minus cos square x and it will be plus 2 sine x and minus sine square x over cos square x. So this is our derivative. This is our derivative. Now for the stationary point, we know that the derivative is equals to 0. So we'll equate it to 0. So it will be minus cos square x plus 2 sine x minus sine square x over cos square x is equals to 0. Because for the stationary point, dy over dx is equals to 0. This is our dy over dx. Now we can further simplify. So it will become minus cos square x plus 2 sine x minus sine square x is equals to 0. In the formula sheet under trigonometry, we are given this identity. It is the first one, cos square x plus sine square theta is equals to 1. So I'm going to write it here. This was our identity, cos theta plus sine theta is equals to 1. Just recheck. Yes, it's the same. So this is the identity which we will be using. So I'm going to rearrange this equation by bringing the cos square and the sine square on the right side. So it will become 2 sine x is equals to sine square x plus cos square x. Now we can substitute sine square x plus cos square x. We can substitute 1 in place of this. So it will become is equals to 1. We are using this identity right here. So it will be 2 sine x is equals to 1. And now to find the value of x, we will divide the 1 by 2 and we will take the inverse. So it will be sine inverse into 1 over 2. You need to change your calculator into radians and we'll get pi over 6. So this is our x value. So let's just rewrite the equation. It was y is equals to 2 minus sine x over cos x. Y is equals to 2 minus sine x over cos x. So I'm going to substitute x value to find y. Sine pi over 6 cos pi over 6. And y value is equals to, for part 2, we have to find out whether the point is maximum or minimum. So for this, we are going to consider our x value, which was pi over 6. So let's write it here, pi over 6. X was pi over 6. Now what we need to do is we need to take any value which is less than pi over 6. So any value, any x value less than pi over 6. Pi over 6. So I'm taking pi over 8 in this case. Pi over 8 is less than pi over 6. And then we are going to substitute into our dy over dx, which we find, the derivative we found right here. Yes, this is the derivative which we found. This is the derivative. So we are going to substitute this value into the derivative and we are going to figure out if the value which we get is minus or plus. So when you will substitute pi over 8 into the derivative, you will get some value in minus. It's around, I think, minus 0 point something, but it's minus, that's what matters. Now we are going to take any value which is greater than pi over 6, which is greater than pi over 6. For instance, I'm going to take pi over 2. It's greater than pi over 6. Then I'm going to do the same thing. I'm going to substitute this value into our dy over dx. So when I substitute it, I will get a value which is a positive value. So as it is changing from negative to positive, it is a maximum point. If in this case it's a maximum point because first it was negative, then it was positive. But however, in some question, let's just say, for example, our first value was positive and our second value was negative. Then in that case, if it's going from positive to negative, then our point is minimum point. But you should keep this in mind that the sequence should be same. Like first you need to find out the value which is less than our x. Our x is pi over 6 in this case, and then you need to find out the value which is greater than x. So this sequence should not change.